Let's go through the code 2934 minimal operation to maximize last element in array. For this question, it gives us an integer array nums1 and nums2. And let's find the minimal operations to maximize the last element in array. So, so the operation is a swap. For the ith index, we can swap the nums1i with nums2i. And we need every array numbers in nums1, where the largest will be the last element, and also every element in nums2, the largest will be the last element. If for the operations we cannot get the last to be the last element, we return -1. So what we're thinking about this is just some kind of simulations, right? So we so there are two kind of scenarios. One is to swap the last element of nums1 with nums2, trying to find the minimal operations to get a solution. Another is we do not swap. So what we do is that if we have two arrays, right? If we don't swap, what we do is that we try to iterate from I to n-2, right? This is n-2. So trying to see if this one is greater than the last element, we try to swap. And for this kind of things, if we do a swap, we have the result increment by 1. And after swap, if this one is greater than swap the second array, the last value, or this kind of value from the second array is greater than the first one's last value, then that means we cannot use the swap to get our result. Then we return -1, right? And then in the end, we compare the two results, the swapped and the non-swapped result. So let's begin to write code for this. And we have n equals. You see that the two array have the same length, right? So we don't need to have a special corner cases trying to see if their length does not equal return -1. And I'm going to write a function called count, called get count. And for this case, it does not swap, right? And this is a swap. And we swap the last element. So we'll say int temp equals numbers1 and -1, right? And numbers1 and -1 equals numbers2 and -1, right? And in numbers2 and -1 equals 10, right? And we'll have let's have this one as count, right? And count1, and this one has count2 equals get count nums1 nums2, right? So actually we just return math.min, right? Count1 and count2, we have one more swap, right? So that at the beginning, so that is +1, right? So how can we handle the special case? That is, if we for example, the count1 or count2, they cannot use a swap to get does not satisfy our result. We retain a maximal value, right? So we can set a private final static int r in f equals integer dot max value. So let's write this private int get count. So nums1 int nums2. So we have int a equals nums1 dot length, and last one equals nums1 dot n minus 1, right? And the last two equals nums2 n minus 1, right? So what we do is for int I equals 0, I smaller than a minus 1, I plus plus. So we'll say if it satisfies the condition that nums 1i smaller equal to last 1, and nums2i smaller equal to last 2, right? We just continue. We don't need to swap. Else we need to swap. But the thing is that if after swap, we still have for example, we have this nums1 i, right? Because this one is still greater than last 2 of the new position, right? So if nums2 dot I greater than last 1, right? In this case, we just return I after. That means after swap, we cannot get a result, right? So we'll have int result equals 0, and result plus plus, and then we return result, right? So the thing is that this one can be INF plus 1, you see. So what we are going to do is doing like this, int result equal this, right? So return result greater equal to INF. Then we have use minus 1, otherwise we use the result. The time complexity should be ON, and then space will also be O. It's constant, right? Constant.